guys, welcome to the video. In this video, I'm going to talk about the secret behind learning any programming language or dealing with any programming language. Well, let me disclose a secret. The secret to learn any programming language or to work on any programming language is building your own logic. If you have that ability to build your own logic, then you can work on any programming language, even those languages which you never worked on. So this video is going to be a video tutorial on logic building in programming, and this video covers this video gives you a basic idea about how to build your own logic for a given task, and with that you will be able to write your own computer programs. So this video will be of two parts. The part you're watching now is the first part. The second part will be in the description below. The link will be in the description below or at the end of this video. So make sure you watch both the parts until the end so that you completely understand what I'm trying to deliver you. So without further ado, let's get started. So welcome to the video tutorial on logic making in programming. I think I have given enough introduction for that, so let's go right into the video tutorial. So first off, what is actually programming in brief? Well, I'll answer that. I'll define programming as an art of making your computer do your work much faster and more efficiently. It's literally a smart way to assign your work to your computer. Why do you need to assign your work to your computer? Because computers have high processing speed and they can do big calculations in a matter of seconds, and they also do it very effectively as compared to your human brain. I'm not offending your brain, but I'm just talking about the processing speed of computers. So that is basically why you want to assign your tasks to your computer. Like, you want to make your computer do your tasks, and that is actually an art, and that art is what we call programming. And then how do you do so? How do you make your computer listen to you? How do you make it to do your tasks? And how do you make it understand what you want it to do? Well, basically you can do that by writing commands or instructions or a set of instructions and executing them on your computer. And if you ask me what actually a computer program is, it's actually a set of instructions which tells your computer what to do. So that is basically the definition of a computer program. And now let's take a simple example. Alright, let's say you want to type or you want to save the first 1000 even numbers into a text file. You want to type it in your text editor like Notepad or WordPad, etc., and you want to save that file automatically as a text file. So if you do this, if you want to complete this task manually, it takes you literally a lot of time, because you need to literally type in each even number ranging from 1 to 1000. So that obviously is going to cost you a lot of time. But you can do this in a matter of seconds or milliseconds. You can simply write a computer program and you can get this task done within a matter of seconds or milliseconds, depending upon your computer's processing speed. And it is also effective way of doing it. So it's like literally telling your computer to write the first 1000 numbers in a text file, and it will listen to you only if you communicate with it in a proper way. All right. So the question is, how do you communicate in a proper way? Let's say this is your computer, and let's say this is you, and you're asking your computer to write all the first 1000 even numbers in your Notepad. And what your computer says is, it says that it can't understand your language, a big sad face, and it asks you to communicate in the language in which it can understand. So in the next scene, there's your computer once again, and there is you, and this time you're going to write a Python code which can print the first 1000 even numbers into a text file. So you're giving this as an input to your computer. You're giving these commands to your computer, and now the computer is going to say task done with a big smiling face, and which means it has successfully done the task which is assigned to it by you. So that is how these things work. And now let's see how your computer actually understood the command that you have given in the previous scene. All right, so what you're doing is you're writing a computer program in a high level language. In this case, I've written this program or this code in Python, and Python is a high level programming language, and you're writing this set of instructions in a high level language like Python, Java, etc. And this high level language is basically converted into a machine code by the compiler or the interpreter or both, and this machine code is what can be understood by the computer. A computer can only understand the machine code. So this high level language, which is written in English language in the sense using English words, all right, and this high level language which may be written in any language, it's actually converted by a compiler or interpreter to a machine code, and this machine code can be understood by your computer. And to write these instructions, as I've told you, you can use any high level or low level languages, like you can use Java or Python or C and assembly, etc. And the code written in any of these programming languages can be interpreted, and it can do the same task. All right, so the programming language doesn't matter. How you are making your computer do your task actually matters, and it all depends on the logic you are using to make your program. And now the big question is how to write this code, and that is why you're watching this video. How to write this code, how to get an idea about how to solve the task. So for example, let's take the same example, Python code to write the first 1000 even numbers into a text file. And this is actually the Python code that I have used earlier, all right, in that little animation I've showed. Okay, this is the Python code that I've used, and please note that in order to understand this, you need not know Python. You need not be having any idea about Python. The main intention of making this video is to make you understand how to build logic. This video is not intended to teach you some programming language. This is not intended to teach you Python or Java or anything. It is intended to make you think about how to build up your own logic. So it doesn't matter if you don't understand Python. I'm just going to explain you the logic but not the code. Okay, anyway, let's go to the first line. The first line is f equal to open and some text inside it, and what this does is it's actually a built-in Python function to create a text file at your C directory. So open followed by open and closed parenthesis is actually an inbuilt function in Python, and using that you can create a file at any destination you want. And this function to create a file varies for every programming language. For example, if you take Java, you might have to use the file writer class to create a text file, but here in the Python you can simply do that by making use of the open function. All right, now let's go to the second line. The second line is actually a loop, and it runs between when the value is between 1 and 1000. Okay, it actually runs when the I value is between 1 and 1000. So just understand that. You may not be having any idea about looping. We will discuss about looping later in this video, but for now just understand that this second line is actually a loop, and it runs as long as the value of I is between 1 and 1000. The third line is actually a logic to check whether the particular number is even or not. And if I read out the line, it's like if followed by open and closed parentheses, and inside these open and closed parentheses I have written I, and that symbol is called as mod in programming. So it's like I mod 2 double equal to, which is known as equalizer, and then followed by 0. So this conditional statement, this is what we call a conditional statement. Don't worry, we'll discuss about conditional statement once again later in this video. So this is a conditional statement, and it is actually a logic to check whether a number is even or odd. So let me talk more about this logic. Let me show you how this logic works. Let's see logic behind the checking whether the number is even. First of all, what is an even number? An even number is a number which is always divisible by 2. That is, whenever an even number is divided by 2, it leaves a remainder 0. It is going to give an integer value. It is not going to give a decimal value. That is what exactly meant by an even number. When divided by 2, it doesn't leave any remainder, or in other words, it leaves a remainder 0. That is meant by an even number. For example, take the number 6, and we all know 6 is an even number. If you divide 6 by 2, what's going to be the output? Yeah, 6 by 2 is equal to 3, and the remainder is equal to 0 because it's not going to leave any remainder. So since the remainder is equal to 0, 6 is an even number. In the same way, let's take another example. Let's take the number 962, and it is also an even number, as we all know. So divide 962 by 2, it's going to be 481, and once again the remainder is 0 because the output that we have got is not a decimal value, so the remainder is 0, obviously. So which means 962 is once again an even number. So this using this thing, we are actually going to build up the logic. Let's see how we do that. So let's go deep into this this statement here. If I mod 2 equal to 0, let's see what it actually does. First of all, the mod symbol is used to calculate the remainder when a number is divided by another. For example, if you say a equal to 5 mod 2, then what it actually does is it's going to divide 5 by the number 2, and 2 divided by 5, if you calculate it on a paper, or if you're good in math, you can do it in your brain, it's going to leave a remainder 1, as we all know, right? So the value of a will be 1 because mod is actually going to return the remainder. So 5 mod 2 is going to return 1 because the remainder is equal to 1. So the value of a will be 1. This is how the mod function, the mod operation works like. So when I said if I mod 2 equal to 0, I am basically asking my computer to calculate the remainder when the number I is divided by 2. The number I is small letter there, so please excuse me for that. So anyways, when I'm writing this conditional statement, I'm basically asking my computer to calculate the remainder when the number I is divided by 2. And after calculating it, I'm asking my computer to check whether the calculated value is 0 by using the equalizer. An equalizer is nothing but two equal to signs followed. One equal to sign followed by another. So in programming, basically we use this equalizer function in conditional statements to check the equality between two values or two variables. Alright, so that is what I'm doing. Firstly, I performed a mod function to return the remainder when I is divided by 2. And if the if the returned value, like if the remainder is equal to 0, then I can come to an understanding that the value I is an even number. So if the remainder is 0, we can say that the number I is an even number. So now let's come back to the code again, and the last line, which is the fourth line, is actually a write function. And what it actually does is, if the condition is satisfied, like if the condition is satisfied, which means if I is found to be a even number, then we are executing the last line. The last line is actually, it writes the number I to the text file, and that too if the condition is not satisfied. Let's say if I mod 2 is not equal to 0, in that case the fourth line is not going to be executed because the condition is not satisfied. As simple as that. So you can remember the last line as it actually does write, or it actually prints or saves the value I to the text file. So you need not know about the function write. As I've told you, I'm not teaching you the programming language, I'm teaching you the logic. Okay, so if the number is found to be an even number, then we are printing it to the text file. Alright, now for the same task, let's look at the Java program, the Java code for the same task to print the first 1000 even numbers to a text file. Firstly, we are importing IO package. Alright, let me show you the code. So this is the Java program to do the same task. Alright, and once again, you need not worry if you don't know how this code works, if you don't have any basic idea about Java. Alright, let me go line by line to just give you a basic idea about what it is doing. The first line is actually importing the package java.io. IO stands for input output anyways. And then we declared a class write file, and then method test, and then we created an object of the class file and file writer. And from here the actual logic starts. We are starting a for loop, and this for loop is going to range when the I value is between 1 and 1000. So as long as the I value is between 1 and 1000, this is going to be executed. So once the I value is less than or equal to 1000, it's going to go inside the loop, and it's going to say if I mod 2 equal to 0. Similarly, like in the Python code, I've used the same logic. I'm calculating the reminder and I'm seeing if it's equal to 0, and if it's equal to 0, just like the Python code, I am writing that number to the text file which we have created. Okay, so this loop is going to run for exactly 100,000 times because the I value is going to be incremented by 1 every time one iteration of this loop is done. So after the first iteration, the value of I is going to be incremented by 1, and the value of I is 2. Like that, it's going to be incremented after every iteration, so which intuitively means that this for loop is going to be executed 100,000 times, and each time the respective number is checked if it's an even number or not, and if it's an even number, we are writing it to the text file. And the last line is actually closing the object. So now let's compare the Java and the Python code. So this is the Java code I have shown you earlier, and this is the Python code. Now what I want you to understand is there might be different ways of writing the code based on the programming languages on which you are working. But the logic you use to do a specific task is similar for every programming language. So what I mean is, one who understands how to develop a logic for a certain task can work on any programming language. The thing is, anyone can learn a programming languages. What is meant by learning a programming language? It's nothing but learning the syntax, and you can learn the syntax by just by hearting and by just memorizing that. But what you can't by heart or memorize is the logic. The logic is something which should come out at that instant of seeing the problem. So as you can see on the left side, we have a Java code which does the same task of printing the first 1000 even numbers into a text file, and in the right side we have the Python code which does the same task. And I mean, no offense to any programming language, but I think Python is a lot simple. Look at this. It has only 4 lines of code, but look at the Java code. It's like little complex. But anyways, I'm talking about the logic. So both of these codes include the same logic. It's only there is only difference in writing the code. So the idea is, there might be different ways of writing a code in different programming languages. Like different programming languages have different syntaxes, different declarations, etc. But the logic to solve the task is same for every programming language. No matter if you're working on Java, you use the same logic. No matter if you're working on C or C++, you use the same logic. No matter if you're working on Python, you use the same logic to solve the same task. What differs between the programming languages is the syntax, but not the logic, as I'm speaking before. And one who has the ability to develop a logic can learn a programming language in a matter of days. As I've told you, learning a programming language is nothing. It's just like memorizing the syntax and all the stuff. But logic is something which has to be developed and built, and it comes on practice. So the last point is actually the same point which I have been talking about, like you can't memorize building the logic and stuff. So I would not like to read that out. The next thing is the basic techniques in programming. So in order to build the logic, you might want to know about some basic techniques in programming. So only after you know these basic techniques, you will be able to understand, or you will be able to build up your own logic. So I'm going to talk about these basic techniques in programming. I'm going to talk about these 2 basic techniques in programming. using which you can build up your own logics. All right. So the first technique I'm going to talk about is the conditional statements. What exactly a conditional statement means is it checks if a condition is satisfied or not. All right. So suppose you want your computer to check whether the entered value is a number or English alphabets. All right. So you can literally tell your computer that if the entered value is a number, then do this task, or if the entered value is a set of English alphabets, then do this task. So you can literally command your computer, you can literally give conditions to your computer, so that if first condition is satisfied, you execute these commands, and if the second condition is satisfied, you execute these commands. So this is the basic idea of conditional statements in programming. If the value is a number, let's say if the value is a number, like if the entered value is a number, you want to print it's a number. And if the value is a set of alphabets, you want to print it's alphabetical. So let's say you want to develop a logic to do this. All right. So let me show you a simple Python program to do this task. So first off, I have initialized the value of a as Teja. So the value Teja is stored in the variable a. And then this is the first condition, if followed by open and close parenthesis, and inside the open and close parenthesis there is a condition, and this is what exactly we term as a conditional statement. So what I said here is if a dot is digit, which means that it's going to take the value a and it's going to check if the value a is actually a number. I mean it doesn't include any letters or any stuff, it only includes a number. All right, we are giving a condition, we are assigning a condition to our computer to check whether the a is a pure number, it contains only numbers from 0 to 9. So we are giving this condition, and if this condition is satisfied, then this statement is printed. It's going to print it's a number. And once again, if this statement or this function a dot is digit is inbuilt in Python, and when I say inbuilt, you have to understand that this is different for every programming language. For Java there might be a different way for do this, and this method won't work, and for C it will be a different way, and for C++ it will be a different way. But as usual, I'm talking about the logic, not about a particular programming language. All right, so this is the first condition, and the second condition is elif. Elif is actually nothing but else if. Okay, and the second condition is I'm saying a dot is alpha, and a dot is alpha, it's a function, it's an inbuilt Python function, and what it does is it takes the value a, and it's going to check if a contains only letters. Okay, so this is a condition, and this is an inbuilt Python function to check if value is alphabetical. And if this condition is satisfied, we are going to execute this statement, this print statement, and it's going to print it's alphabetical. So the general form of conditional statements. So if condition 1 is satisfied, then execute these set of statements, and those set of statements can be statement 1, statement 2, statement 3, so on until statement 10. It can be any number of statements. Okay, and this is the first condition. And if you want to declare another condition, if condition 2 is satisfied, then execute these set of statements, and these statements can be once again statement 1, statement 2, statement 3, so on, statement n. These statements can be similar, they can be different, anything, they can be any statements, and these statements are only going to be executed if their parent condition is satisfied. Okay, so you have to note that. And let's go to our scenario, checking whether a value is a number or an alphabetical. The condition 1 in our case is to check if the value is a number. The condition 2 is to check if the value is alphabetical. So this is the Python code that I've used, I've shown you earlier. And the first line actually checks if the value a is a number or digit, and this first line, the first if statement, is actually the condition 1. Okay, I've explained you earlier, this is the condition 1. Okay, and the second line, which is the print statement, executes only if the condition 1 is satisfied. See, if the condition 1 is satisfied, it executes this print statement. Okay, and the next line is a condition statement to check whether value a is an alphabetical value, and this is the condition 2. Okay, and the next line, the last line, is a print statement, and if the condition 2 is satisfied, it executes this print statement. So I think now you got a basic idea about these conditional statements. Okay, assigning conditions and doing stuff out of it. So one important note is that the syntaxes of these conditional statements vary for each programming language. I mean, each programming language have different ways of doing these conditional testing in your program. So it varies for each programming language. You have to note that. Okay. That's all with the first technique. Now the second technique is looping in programming. And what is exactly looping in programming? It's a way of repeating a set of statements in a program more than once, or just once, or infinite number of times. The statements in a loop are executed repeatedly as long as the condition specified the programmer is satisfied. So there are many types of loops like for loop, while loop, and do while loop, and the syntax to be followed varies for every programming language once again. Okay, and well, before coming to this slide, let's talk more about looping. Let me talk about looping. Let's say you want to execute a set of 3 statements more than once during the execution of program. So in that case, you can start a loop. For example, let's say for loop, and using that for loop, you can make those set of 3 statements execute 3 times. So each statement is executed 3 times. So I hope now you have some basic idea. If you don't get that idea, don't worry, you're going to get later in this video as I proceed. So let's take the logic to print the first 1000 natural numbers, and this is different from the previous example. In the previous example, we have taken a logic to print the first 1000 even numbers, but in this we are printing the first 1000 natural numbers, which is literally 1 2 3 4 5 6 7 8 and until so on 1000. So if you want to do this without looping, you might have to print each and every natural number from 1 to 1000 using a separate print statement, just like this. You will say print 1, and then you say print 2, print 3, so on, print 1000 until print 1000. So basically, intuitively thinking, that's going to give you 1000 lines of code, and all those lines of code are actually print statements. It's going to print each and every single value of the natural number ranging from 1 to 1000. So let's look at this. By using a loop, we can do this by using a single print statement. So instead of typing 1000 print statements to print all the first 1000 natural numbers, you can use a single print statement. You can make that print statement to execute 1000 times. In that way, we can print all the first 1000 natural numbers. So we can start a loop which runs when the value of I is between 1 and 1000. Okay, so the loop runs as long as the value of I is between 1 and 1000. So as long as this condition is satisfied, the loop will repeatedly execute. So inside this loop, we can print the value of I, which will range between 1 and 1000. And one thing I want you to note is, for every iteration of this loop, the value of I is going to be incremented by 1. For example, for the first iteration, the value of I is 1. But for the second iteration, the value of I is not going to be 1. It's going to be incremented by 1. What I mean by incrementing by 1 is I equal to I plus 1, which means I value will be 2 for the second iteration, and we'll be printing the value 2. And in the third iteration, the value of I is 3, we'll be printing 3. Fourth iteration, the value of I is 4, we'll be printing the value of I, which is 4. And like that, it continues until the value of I reaches 1000. And once it reaches 1000, the loop is no longer going to be executed because the condition fails, and because at 1001, it's no longer going to satisfy the condition, so the loop is terminated. That's a basic idea of looping. So the last point is the same. The value of I changes for every iteration. Alright, now let's go and look at a Java program to do so. So first of all, we declared a for loop to do this. And then we are printing it. We included one print statement, and that's it. That is all about printing the first 1000 natural numbers using Java. All right, now let's go ahead and let's see how this program actually works. So this for loop, actually we initialize the value of I as 1. As you could see, for int I equal to 1 followed by a semicolon, what we are doing is we initialize the value of I as 1. So the value of I will be 1 initially, and we are checking if the value of I is less than 1000. So after this semicolon, after the first semicolon, we can see a conditional statement there, I less than or equal to 1000. Sorry, that's, I've written 100 there, but it's 1000. That's a typing mistake, so please excuse me, please don't mind that. Anyway, so we are checking if I is less than 1000. Alright, that is a conditional statement. And next, if this condition is satisfied, if I is less than or equal to 1000, we are executing the print statement inside the loop. So the system.out.println is the basic print statement which we use in Java, and inside this print statement we are actually printing the number I, as you could see. So the print statement prints the value of I. Okay, so as you could see, it's printing the value of I. And next, the value of I will be incremented by 1, that is I equal to I plus 1. And this we are indicating by saying I plus plus. After the second semicolon, you can notice one I plus plus. I plus plus is nothing but I equal to I plus 1. It's another form of writing I equal to I plus 1. So after each iteration of the loop, we are incrementing the value of I. So for the first iteration, the value of I is 1, and after that it's going to be incremented by 1, which means it's going to be equal to 2, and we are printing the value of 2 using the system.out.println statement. Like that it's going to work. So the condition is now again tested once the value of I is incremented, like from 1 it goes to 2, and the condition is again tested. It's going to test whether I is less than or equal to 1000, and if it satisfies, the process once again repeats. And if the condition fails, the loop will quit. And when will the condition fail? As soon as the I value reach 1001, the condition is going to fail, because I is now no longer less than or equal to 1000. So the condition is going to fail. And what means when I say condition is going to fail, it means that the loop is going to be terminated. And now let's talk about nested looping. Nested looping is not any much different than this normal looping. So nesting looping is actually one loop inside another loop. You have multiple loops, and one loop is written inside another loop. That is what we call nested looping. As the name suggests, you can intuitively think of it. So let's say a loop 1 is started like this, and inside the loop 1, loop 2 is started. Loop 2 is started inside the loop 1, and inside the loop 2, loop 3 is started, and inside the loop 3, loop 4 is started, and so on. Loop n is started inside loop n minus 1. So this is what exactly we call nested looping. In a nested looping, there may be n number of loops. Okay, one loop is written inside another loop. And why do you need to do this nested looping thing? Because in order to build your logic, you might want to use this nested looping, and it depends on the way you are building the logic. So let's take an example. For example, we want to print out the following pattern by making use of our logic. So this is the pattern. So we want to print out this pattern actually. So we want to print out a pattern like this with asterisks or stars, whatever you call. So now we will look at the logic, or we will build a logic to print out this pattern in any programming language. But we'll not be doing this it in this video, because I think I don't have any more time to finish this in this video. So go ahead and check out the part 2 of this video, where we'll be continuing this tutorial from here. So go ahead and check out the second tutorial. The link to the second part is going to be in the description below. Go ahead and click on it to watch the continuation of this video.